Type soil moisture sensor into a search box and you fall into a war. On one side, a plastic probe for about 9 pounds. On another, a glass gauge on a water-filled tube, like something from a chemistry set. Behind both, a metal lab instrument priced like it escaped a university. Here is the question. These three do not measure the same thing. Which tribe belongs in your garden? I am Michal. I drive buses in Belfast. In your garden. First, an honest question. Series 1 taught the finger test, and it still wins. 5 to 10 centimeters down, free, no batteries. So why buy a sensor at all? 2 reasons. The first is the shift pattern. At 5 in the morning, I am driving a bus, not standing in the allotment with my finger in a bed. A probe is a finger that stays behind. It keeps reading the bed while I am on shift. My own finger only reads it when I am home. The second reason is scale. One finger check tells you about 1 handful of soil once. Automation people worked this out years ago. One post on the home automation forums showed a whole backyard irrigation rig built around soil moisture readings feeding a home server. And 300 people upvoted the ambition. The old boys at the allotment forecast rain with their knees. I use a probe. Everybody has a system. But the moment you decide to buy one, you meet the war from the top of the show. 3 tribes, 3 completely different instruments, all sold under the same name. The confusion is not your fault. Nobody selling them tells you they measure 3 different things. So let us meet the tribes one at a time and find out what each one is actually listening to. Tribe 1 is the crowd, the plastic probes, the cheap and cheerful ones, the type wired into nearly every home smart garden kit you can buy. They are capacitance sensors. And here's the secret that explains both their price and their flaws. The probe does not measure water. It cannot see water. It sets up a tiny electric field between its blades and measures how the surrounding soil changes that field. Dry minerals barely answer. Water answers loudly. Water is by far the loudest voice in that electrical conversation. So the more water around the probe, the stronger the response. And the electronics translate that response into a percentage on your app. Notice what that means. The reading is an electrical estimate of how much water sits in the soil around the blades. Estimate is the operative word. Anything else that changes the electrical character of the soil leans on the number. Salts lean on it. Fertilizer leans on it. The type of soil itself leans on it, which is why the same probe can talk sense in one bed and nonsense in another until it is calibrated. We will sentence those sins properly at the end of the episode, but do not dismiss the crowd. No moving parts, no maintenance, cheap enough to buy 1 per zone and happy to chat to a hub all season. There is a reason this tribe won the home market. It turns soil into a number for the price of a takeaway. Tribe 2 could not be more different. The tensiometer is a mechanical monk. No battery, no Wi-Fi, no opinions. Just a sealed tube full of water, a ceramic tip for a nose, and a vacuum gauge for a face. And the monk measures something the crowd never even considers. Not how much water the soil holds, how hard the soil is holding it. It works like this, and the mechanism is quietly lovely. The ceramic tip is porous, so water can pass slowly through it. As the soil dries, it starts pulling water out of the tube through that tip. The tube is sealed, so every drop the soil steals creates suction inside, and the gauge reads that suction. Dry soil pulls harder, the needle climbs. Now why is that beautiful? Because that pull is exactly what a root experiences. A root does not know percentages. A root only knows how hard it must work to drag the next drop out of the ground. The monk and the root are measuring the same thing. That is why the trade says a tensiometer comes closest to how the plant actually feels. It also needs looking after. The tube wants topping up, the tip wants care. It is an instrument, not a gadget. But here's the thing. If this tribe measures the only quantity the plant truly cares about, why has it not conquered the home market? Hold that thought through Tribe 3. Tribe 3 is the laboratory, TDR and its cousin FDR. names you meet on instruments that measure soil moisture by sending electrical pulses along metal rods and timing how the soil answers. The physics is elegant, the accuracy is the point, and the price is the punchline. It is wonderful, it is precise, it costs more than my first car. Moving on. Well, almost. It is worth 1 minute of respect, because this tribe explains what accuracy actually buys. A university running a field trial needs readings it can defend in a journal. A farm irrigating hundreds of acres against a water quota needs numbers solid enough to bet money on. At that scale, the difference between roughly right and precisely right is worth thousands, so the instrument pays its way. Your raised bed does not have a research budget, and it does not need one. Nobody is peer reviewing your courgettes. The decision you are making is water today or wait until Thursday. A well-behaved cheap probe answers that question perfectly well once it is calibrated. So the laboratory tribe is not wrong. It is just answering a harder question than the one your garden is asking. Let it go back to its field trials with our blessing, which leaves 2 tribes standing in the home garden final. So, the crowd against the monk. To judge them, run one small experiment in your head. Take 2 pots, one filled with sandy soil, one with heavy clay, and let both dry for the same few days. The capacitance probes report how much water remains, and the clay pot scores higher, because clay hangs onto more water. But ask the monk, and the story can flip. Clay grips its water so tightly that the roots may already be straining, while the sand, holding less, gives it up easily. Same garden, same day, 2 honest instruments telling different truths. The crowd counts the water, the monk weighs the effort. Neither instrument is lying, they are answering different questions. And Series 1 taught us it is the effort that wilts a plant, not the count. So the monk wins on truth, but the final is not judged on truth alone. The monk is dearer, wants regular topping up, and does not naturally speak Wi-Fi because it is a gauge, not a chip. The crowd is cheap, tireless, speaks to your hub all season, and its 2 sins are both fixable habits rather than flaws in the physics. For a home garden, that settles it. Buy the crowd, calibrate it, and let the monk remain what it is, the professional's instrument, and the reason we understand what our cheap probes are only estimating. 1 honest minute on kit. Whatever tribe you pick, a sensor only ever answers one question, now or not yet. Somebody still has to act on it. And a sensor without a valve is a smoke alarm with no fire brigade. At my house, the fire brigade is the Johgee 4 zone on the outdoor tap. The probes tell me the greenhouse bed dries faster than the pots, so Zone 2 waters on a tighter schedule than Zone 3, each zone on its own timetable. That pairing, reading plus schedule, is the whole system, and the honest bit. If you run 2 or 3 pots, you need neither half. Your finger and a watering can already do both jobs, free. Before you order a bag of capacitance probes, the sentencing. The crowd carries 3 sins, and you should know them before trusting it with a hose. Sin 1. It is sold uncalibrated. Out of the box, its idea of wet and dry belongs to no soil in particular, and certainly not to your patch of heavy Northern Irish clay. The fix is simple and takes minutes. Read it in your soil bone dry. Read it again after a proper soak, and treat those 2 numbers as the ends of its scale. From then on, it speaks your dialect. Sin 2. Salt and soil type bend its numbers. Remember, it measures an electrical conversation, and fertilizer joins in loudly. Feed a bed heavily, and the probe can read wetter than the truth. Knowing that is most of the defense. Sin 3 is the big one. One probe is asked to speak for a whole bed, and soil is not uniform. Wherever the blades happen to sit, that spot becomes the garden's official truth. Put it in a dip that stays damp, and the whole zone goes thirsty on its word. Put it under the one leaky dripper, and the zone drowns instead. Same story in reverse. Placement is such a deep trap that it deserves a full episode. It gets one. Next week. For tonight, just hold this. The probe never lies about its spot. The question is whether its spot tells the truth about your garden.